Hey guys, we're back. So we got one more video on ellipses, and this is kind of the main application of ellipses, okay? So we have an example here of, let's say that this is like a big mirror, a mirror at a science, facility, and according to this is obviously like half of an ellipse, but again, it would keep going around. But again, they built the room so that it would reflect as an ellipse. Okay, here's our focal point. Over here's another focal point. Okay, and then the distance from that center is right there, okay, out to the reflection point. So what we have, again, similar to what we did on the last video, I have a reflection right here. So light, if there was a light here and it shot up to that mirror, it's going to reflect back down to this other focal point right here. So again, because we know that's an ellipse, if I shot some light, it would bounce and come right back to this other focal point. And basically the question is going to be, how long is that light, the distance of that light? How far did that light travel to go from this position, bounce off the ellipse, and come back to that other focal point? Okay, so that's going to be the question. How far did both of these so this blue line up to here and this blue line back to here? Okay, now again, we're still using our a squared, b squared, c squared. Excuse me. Remember, guys, this is 90 right here. This one's 90. Okay. Now, what's a little tricky here is they're telling us this whole part right here is 12. See that? This whole thing across here is 12. But guys, remember, this is coming straight down. And actually, if I put a dot right there where that arrow touches, that is halfway in between there. So really, guys, this distance, if I'm looking at just either one side or the other, this triangle, let's go ahead and look at the one on the right. This distance is only half of 12, so it's actually only 6. See that 6 right there? So from the center where that comes down out is only half of 12. So really, the first a squared or whatever, the first distance right there of my right triangle on the right side here is 6. Now this height would still be 18. See that? That's still 18 from where it touches all the way up. So that is still 18 squared. And again, the blue dotted part is the hypotenuse. See the right triangle there? On the right side, there's a right triangle. So I'm still solving for c squared. Okay. Now, I kind of said this on the last video. Okay, this is going to come out decimals most of the time. On the first video, I just wanted to give you numbers that weren't going to be decimals. But most of the time, it's going to be decimals. So you're going to need to use your calculator again. 6 squared. We can do that one in our head. 6 squared is 36. Okay. Plus 18 squared. Okay, so 18 squared. Whoop, hit the wrong button. 18 squared. Okay, that's 324. Okay. We're going to go ahead and add these together. I can kind of do that in my head. 360. Okay, so 36 plus 324, 360. And then remember, guys, I'm solving for c, so square root. Okay, and again, this is going to be a decimal. We're going to round it to 1 decimal like we usually do. Okay, so again, square root of 360. Okay, ooh, this one's interesting. Okay, 18.97. Okay, now again, remember, we underline the first decimal and we round because that's a 7, that 9 has to carry up to a 10. So actually 18.97 is going to go all the way up to 19. Okay, now again, our units were feet, 19 feet. Okay, now again, that one, that's kind of a little tricky one. That's good. I just made this one up, so I didn't know what we were going to get. Okay, now remember, guys, what we just found is this blue line's 19. But guys, we want to actually say how far did the light reflect completely. So this one would also be 19. I mean, this is going to be 6 right here as well. That's 18. So this is 19. Okay, this distance over here is 19. So 19 plus 19, or 19 times 2, however you want to think about it, okay, is actually that reflection. So the light would actually move a total of 38 feet. See, 19 and 19 makes 38, so that light reflected 38 feet. Okay? Again, let's try another one here. Okay? You can kind of see this one over here. Okay? Let's say that I was talking about this before. Again, if you've ever been to Blossom Music Center, okay, they have concerts there in the summertime because it's kind of an outdoor. The back of the stage is circular like an ellipse, okay? Because, again, it reflects the sound out for a big open air venue like that, okay? So let's say that the focal point here of the speakers, okay, so they're going to set up speakers, is one's here and one's here, main speakers, okay? That distance in between the two speakers is 40 meters. Okay, and then the distance, that vertical distance is 50 meters from the back of that ellipse. So very similar, we want to say how far does that sound travel, okay, if it bounces off the ellipse from one speaker to the other, okay? So again, very similar to the other one. Remember, this whole thing is 40. That whole thing across is 40, but remember, when this line comes down, it's cutting it in half. Okay, so that dot right there is only half of 40, so actually we only have 20. We have 20 on each side. 20 from this dot up, 20 from this dot down. Now this whole thing is 50, so that's not getting cut, but the 40, see, the 40 is getting cut. When that line comes in, it cuts the 40. So really what we have is 20 squared plus 50 squared. That's what's going to give us, again, we're trying to find the dotted line, which again, that's our C. Okay, our C is the dotted line. And again, remember guys, that's a 90. That's our hypotenuse right there. Our right angle, and then C is our hypotenuse. Okay, so again, these are some big numbers, so use your calculator. It's going to come out a decimal. 20 squared is 400. Okay. 50 squared is 2,500. Okay. 400 plus 2,500. Okay, that's kind of something pretty easy to do in your head. 2,900. Okay, remember, just like before, now that I'm at square, I'm going to square root. Okay, so now square root of 2,900. And again, we're going to round to one decimal. 5385. Okay, I underline the 8 because that's a 5. 53.9. Again, this was meters, 53.9 meters. So again, this is 53.9, but remember, it's reflecting. So the other dotted line would also be 53.9. So I actually have 53.9 twice. That's really what, 53.9 and 53.9. So the easiest thing would just be 53.9 times 2. And actually that whole distance, so this whole distance reflecting off of that back wall would be 107.8 meters. Okay, 107.8 meters. Okay, so that's that distance of the blue line reflecting off the back of that ellipse wall. Okay. Okay, again, hopefully that's not too big of a deal. Let me just fix this before I show you the homework. Okay, so again, very similar on your homework. Okay. Hopefully you can see that well. Okay, I'll move back. Okay, so again, you can see the ellipse here. You got the ellipse. Okay, that's 30 feet. This is 42 feet, that distance. Okay, we want to find the sound reflection. So the blue line bouncing off the ellipse back to the other focus point. How long the distance reflection there? How long did that sound reflect off of that ellipse? So again, that's 30 feet. That's 42 feet. Okay, just solve that. Put that into the journal and you'll have it, okay? Okay, guys, we will see you next week. We're only going to be doing 3 videos this week, guys. Just 3 videos instead of 5, okay? So just get your work into the journal and you'll get it into Echo, okay? See you guys. Take care. Bye.